This is testing for the A-level project which I'm building for the character recognition. This system can be used for any project such as the ANPR, automatic number plate recognition. Um, this this project has two main folders: the Holding MNIST and the script. The Holding MNIST has two main datasets: the MNIST dataset and the MNIST test and MNIST train dataset. The script folder has four classes. The reader class is used to read the MNIST test and MNIST train dataset and use them in the actual data array. The reading being the function used here, it uses the path of the dataset and then stores each row of the 2D array, actual data array, as one image, which contains 785 elements. If we go to network.cs, in network.cs we have the reading the we have two classes named testing D, which is um, the training D, which is the training data set or reading the training data set, and testing D, which is reading the testing data set .csv. If we look at the function, for example, compute takes in this example, since this function is used for the evaluation part of near the end of the network, as the network runs. It's not 200 images anymore. We're doing it for 500 images, between 0 and 60,000 images. So what this does is it will run through, and if we look at the array, this array which contains each line of the CSV file which represents each image, 784 elements, 785. Since we don't need the first one, I created the first element of the CSV file array of each line, which is the label, and we don't need the label to run through the network. So I have another array called stringx with data only, which stores everything from the first element of the array onwards. So it's everything excluding the label. In my neural network, this is the structure of the network. Please note, I do not have a general network. It's only 4 layers, one input to hidden, one output layer. If I'm using loaded weights and biases from weights_biases.txt file, then boolean loaded weight should be set to true. If it's set to true, then it just reads the network from this file. The network from file function reads the weights first into each respective matrix, and then the biases. I have a feed forward function, a forward prop, as I've called it here. After the forward prop, I have the back prop. The back prop has these elements of the forward prop copied in as it's running through the network, so I don't have to call forward prop again and again. It makes it easier and reduces errors for me for the network. So in this, if we go to program.cs and if we run the network, with 784 nodes in the input layer, 128 in the first hidden, 64 in the second, and 10 in the output layer. We have set it to true because it is using this network is running on the weights_biases.txt, the data from here, since I had trained it with these weights and biases before running it now. So these are predetermined from the test runs I had done before to find these weights and biases. The function used for this is the start learning function from the network.cs. So the start If I can just find it here, the start running function, this is what it uses. Each epoch in this takes approximately, or based on my recent test, approximately a minute plus um, to do each epoch. Um, Please do take into account that this system or this neural network is running through all the test data and not just one specific image. So it runs through all the test data and then see to check whether the um, to check the accuracy of it. So after approximately a minute, the accuracy is only 5%, which is not high on the first epoch. So if we go down to here, the way it does it is so um, it, after collecting this array with data which contains the image, it runs it through the forward pop, and it has a target array with 10 zeros, each zero representing 0 to 9. From there, the D represents forward output dot max, which is the maximum element, the highest value after the forward propagation has run through, and the evaluation bit for compute. And the targets.max is the maximum value, which would be the first element, representing the first or um, the element from the this array dot zero, which corresponds to this. So it would be the 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. The targets.max, the targets.max is the highest value from this array. If the forward dot output the maximum value matches to this, then it would say that this is a correct guess. Correct guess is then used to calculate the average or the mean or the accuracy of it. So that would be the correct number of correct guesses divided by the total number of images that we have read in each epoch, which I've set to 500. Um, this here means a random. This basically just takes out a random array between that value and then runs it through the network. After the second epoch has run, we are at 13.8% accuracy approximately. After the third epoch, we are at 23.5% accuracy. While this is running, I will also show the other classes that I have built. The MNISTreader.cs class was designed when I was using the zip files. Um, each zip file has when I use so each since I'm not using the zip files anymore, this will not be utilized. However, this only shows the purpose of this file and why and how it will be utilized, how it should have been utilized. So it has a class called image data. Image data stores um, the attributes of the definition of each image, so the height, the width, the number of pixels, and the um, label of each number. So if it's either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, from 0 to 9. Then we have the load files, which uses the image data and returns a 1D array of all the images. And then we use this image data, the load data function, to in here to the load files function and assign it to an image data array, 1D array, and store the data as a BMP, as a bitmap. The other file I've used is I've designed is to format the image. The name doesn't really justify it since I've not completely implemented it. But what it does is it uses MGU, which is a wrapper for OpenCV for C Sharp, and then from there on it identifies where the text is and basically just identifies the text itself. So after the fourth epoch, we're at 28% accuracy. Just once more to clarify, this network does not just look for one, does not just identify one specific image when provided. It runs through all the data set of 500 random images of the data set, and then from there, it basically, after the training's done, then it basically sees whether, checks whether the image from the test matches the output from the network, as I've shown here in network, the forward output from forward prop and the target. So the target is 0 to 9, and the forward prop is the output from the network. After the fifth epoch, we're at 37% accuracy. After the sixth epoch, we're at 46% accuracy. After 7 epochs, we're at 56% accuracy, which is a 56% accuracy, which is not the I'd say not the worst. Now, if we go to the format.image, which I mentioned before, the format.image class essentially just identifies what section of the what section contains the text. Oh, this does not run anything. Let's format the image. 86. So now if we run it, it basically gives us which section contains the text. Once more, I've not utilized this, so this will not be used, but this just shows how it works. And by not utilized it, I mean I've not had a user interface with this, since this is only a console app. Please note that the code in this application can be changed, and I believe some will be changed. So please do take that into account. Thank you.